Hello and welcome to PVCAD Training. Thank you for joining the presentation. If you have any questions about this demonstration, additional information will be included in the description below. Please feel free to reach out to me directly with any questions or comments about this presentation or specific questions about PVCAD. And if you need additional training or demonstration, we can set up additional demos, one-on-one demonstrations with you as needed. So this is PVCAD, what we're looking at currently. PVCAD is a extension for AutoCAD. So if you're using AutoCAD, you can add our PVCAD tools to create a environment which gives you additional solar tools inside of your existing full version of AutoCAD. We also have PVCAD Bundle. PVCAD Bundle is software that comes with AutoCAD together. So you get AutoCAD and our software together in one piece of software, so you don't have to buy AutoCAD, a full version of AutoCAD, if you don't already have a version of AutoCAD. So whether you have AutoCAD already or you don't have AutoCAD, we have a solution for you where you can use PVCAD solar engineering software to help you create plan sets or advanced designs for solar. PVCAD, as I've just mentioned, is advanced solar engineering software, and it is designed specifically to create plan sets that you can use to pull a permit all over the country or all over the world and have a construction drawing set so you can actually build a project. If you're familiar with AutoCAD, this is very similar to the regular AutoCAD layout. You have Home, Insert, Annotate, Parametric, etc. along the top. In the very last tab, we add this tab called PVCAD. And you can see at the top here you have Import from PVSketch, Export Bill of Materials, Energy Simulation, Single Line Diagram, Database, etc. These are all the main tools that we're going to use to expand upon AutoCAD's capabilities and make it more solar capable when you're making a residential, commercial, or utility scale solar project. What I have opened right now, Drawing 3, this tab at the top, is a basic template that we provide as part of PVCAD for you to do your drawing in. We have these templates in metric and imperial in a couple of different sizes, and we can also help you customize this template if you want to make changes to it. Essentially what happens is as you work in your model space, the drawing space where you're creating the actual solar field or array, all of that information is going to be carried over into this paper space, these pages, as this is what will actually get printed out for your document. So you can see here this PVE1 is site plan and general notes, PVE2 is array layout, PVE3 single line diagram, PVE4 electrical calculations, so on and so forth. And all of these pages are set up to represent what a typical plan set would look like in most cases. But of course, this is an editable file. It's a DWT file inside of AutoCAD that you can change and customize to aesthetically show whatever you want to show, from the layout of the page itself to the order of the pages to the number of pages, etc. The only important bit of information when it comes to the PVCAD templates to keep in mind are these fields. You can see it says module name, inverter, tilt angle, number of modules, DC string lengths, number of strings, etc. All of these fields that are populated in the template are done so automatically, which allows you not to have to worry about copy and paste errors or counting errors that might take place, or how many modules do I have, how many strings do I have. The software will tabulate all that information for you and populate it onto the paper space, so you don't have to retype any of that information after you've generated the design in the drawing space or the model space. You'll also see at the end here there's a sheet called Extra Fields. This Extra Fields tab gives you all of these different categories, which are the fields that we can pre-populate for you, such as product latitude, longitude, meter direction, inverter, system size, etc. And so you can move these fields and essentially create your own template. And again, we can help you do this, but you can create your own template to appear in any order that you want. So now moving back, if I click on the Model Space tab, this is what the model space will look like. Now right now I'm using our Iron Ridge template, and inside our Iron Ridge template we include this side cutout of the racking in the model space. If you're using another template, you will not see this side cutout. But it's not important if you don't have it. All of the following drawing that I'm going to show you will not change regardless if you're using the Iron Ridge template or if you're not using the Iron Ridge template. Now, to start a project, after you have your open template and you have you want it to be saved as a drawing file, a .dwg file, you're going to notice at the top here a Show Dialog button. You're going to want to click on the Show Dialog button, and you're going to see a window that looks like this, where it says Project, Site Objects, Version Settings, Mechanical Layout, Electrical Layout, and Summary. These are the main tabs in which most of the information about the project is going to be contained. So essentially, you're going to be working your way through this project. You're going to start on the left with Project. You're going to go to Site Objects, then you're going to work on Version Settings, Mechanical Layout, Electrical Layout, and then Summary will be the last tab. It'll have all the information about the project created. So we're working left to right typically. Of course, you can jump around as needed, but that is the general direction flow when you're working inside of PVCAD. Now, to start a project, there are a couple of different ways to go. If you are in a full version of AutoCAD and you're using our software, you'll see under the Project tab in this dialog window there's a button that says Set Location. I can click on Set Location, and then what will happen here is you see at the bottom it says Geographic Set Location from Map or File. You can see Map or File. If you click on Map, what will happen is AutoCAD will open up its geographic location satellite imagery capability, which is provided by Microsoft Bing. You have to have A360 installed and you have to be connected to A360. If you do not have A360 connected, you're going to have to connect. It will prompt you to sign in when you click on that map file. But after you sign in, this is the imagery you're going to see. At this point, you can type in any address on the globe. Say, okay, here is my location. You can pull up any rooftop. Say, here is the rooftop I'm working with. You're going to right-click on your mouse, drop a marker, click Next. Select the top set of coordinates, and then you can press Enter on your keyboard twice and it will bring in the satellite map for you, and then you can begin drawing your ground mount project, your rooftop project, or your carport project. Any type of project that you're working on, you can either begin drawing on top of the roof, on the ground, or on a carport. Now, the other way to do this, so this is if you're starting from scratch, you have nothing there. There's another way you can go about this. So if I started a new project and I didn't have, maybe I don't have the full version of AutoCAD, maybe you're using our bundle version, or you have existing imagery. Maybe you have some really high quality imagery that you want to use. What you can do in that case is you can go to Home, you can go to Insert, click on Attach, and then go to an image. Let me find a good image here. So you can go to an image, a satellite image that you want to use, click Open, click OK. You can see as I move my mouse back and forth, it's going to size the image, but it's not too important at this point because we have to scale the image first. So I'm going to bring the image into the drawing, then I'm going to select the drawing, I'm going to type in Scale for the Scale command. It's going to say Specify Base Point, so I'm going to click in the model space. It says Specify Scale Factor, copy a reference, we're going to use a reference point, so I'm going to type the letter R and press Enter. And then it says Specify Reference Length. So what I have to do now is click on two known points in the object. So I'll click here, and I'll click on this bottom left-hand corner. And now it says Specify New Length. So I'm working in inches, So what I have to do now is type in the length between those 2 points I just clicked on in inches. So if they were 2,000 inches, I'd type in 2,000, press enter, and now my object is in the correct scale. So now I can begin drawing on this imagery, this PDF file or whatever you might be using in the model space in the correct scale. So when you are generating modules, generating a layout, everything will be precise and you won't have to worry, is this accurate with the correct number of modules. This object is going to come in as a layer. So if you go to Home, Layer Properties, you'll see it comes in as a layer. All of our PVComplete, all of the different drawing elements in PVComplete come in as a layer. So you can see this is just layer 0. You can adjust the visibility on and off as you could with any other layer. Here's PVC attachments, carport, conduit, combiner box. Just as another note, if you come into these layer properties, you can freeze and lock layers. You can turn the visibility of layers on and off if you want to play with them, depending on what you want to show while you are doing your design. So jumping back to our original drawing on the satellite imagery, I'm going to do an example of a ground mount project today. So let's find a good piece of land that we can work with, and I'll give you an example of how you can do a ground mount project. So this is the Bay Area. This is Berkeley Marina, and so we're going to build a solar field right next to the park in Berkeley Marina. So now that I have my area that I want to work with, I'm going to click on my Home tab, and after I click on my Home tab, I'm going to click on Polyline, and I'm going to outline the ground mount area in which I want my solar array to go. Now this is the same if you're working on a rooftop design. Simply what you want to do is outline the shape of your roof. And when you're done outlining the shape of your roof, make sure it's a closed polyline. You can't have an open polyline. If it's an open polyline, it won't be able to define it in the software. So you have to make sure it's closed. And then after you have your shape, we're going to go back to our dialog window. Now remember, we're moving typically left to right. So the first page is just project information, and you can fill all this out if you'd like. You don't have to do design, but it's the information that will be carried over to your paper space, such as the project name, description, address, phone number, meter type, meter number, etc. The next tab is Site Objects, and Site Objects are categorizing or labeling all the different things that you draw in the model space. So since this is a ground mount, I'm going to click on Object Type, and I'm going to go down to Ground Mount Outline. I'm going to select Ground Mount Outline. If I want to give it a setback, I can give it a setback by typing in the number, 120 inches for example, or you can work in meters. And then I can click Define. And then if I move over, push Escape on my keyboard, I will see that this is now a yellow line, and so I know I have successfully categorized this line as a ground mount outline. Now I have a lot of options. Something I can do before I actually put modules on here is you want to prep the area as best you can to reflect the actual situation in the area that you're installing, whether it's a rooftop or a ground mount. If you need to add obstructions, or maybe there's a maintenance pathway or a walkway or a break in the modules. The way the software works is you set up an area in which you want to completely populate with modules or with trackers. And so the software will fill out that area entirely unless you tell it not to, meaning you've placed an obstruction or some other object in the way. So for example, if I wanted to have a maintenance pathway through the center of this field, I could use my rectangle tool and say, okay, I don't want anything to go in this area. So I'm going to grab this line again, I'm going to highlight it, you can see it turns blue. I'm going to go over, and I'm going to go back to my Site Objects tab, and I'm going to choose Obstruction. You can see any obstruction has a height and a setback. Because this is simply an area in which I want no modules to go, I'm not going to give it a height, because if I gave it a height, it would cast a shadow. But I am going to give it a setback, 24 inches. So it'll be 24 inches on the outside of this line. To just give myself a little bit of an extra buffer, I can click Define, and now this is one obstruction, and now no modules will go on the interior of here. Well, now if you're working on a rooftop, or maybe there's a solar field, or there's a wind farm next by, or there's a tower or a building or something that may cast shade into your solar field or onto your rooftop, you may need to add height on some of those objects. So let me show you what that looks like. Let's say you have an object here, and here I'm using the circle tool. Maybe you have a circular object, a tree, a bush, a wind turbine, something like this. You can highlight it. You can see it turns blue. Again, I'm going to go back to my obstruction, and now I'm going to give it a 24-inch setback again, but now I'm going to make it really tall. I'm going to say it's 270 inches tall. Now when I click Define, it's going to be a little hard to see, but if we look closely here, you can see there's a yellow line, a setback line, and here is a shade line for that object. So this object is now casting shade over the field. And what our software is going to do is when we generate a design, it's going to avoid placing modules or trackers anywhere in which this shade path is calculated. Now, you may be saying to yourself, well, what if I want to change how that shade is calculated? Well, great question. So if you click on PVCAD, the tab at the top, and then you click on your Settings button, you're going to see at the bottom shadow parameters and solar position. So you can choose, do you want this to be summer solstice, equinox, winter solstice, and you can also choose your time interval, 6 a.m., 7 a.m. to 5 p.m., 8 a.m. to 4 p.m., 9 a.m. to 3 p.m., etc. So you can choose what time of year and what time of day you want these shadows to be expressed. Click OK. So at this point, I think the satellite imagery has been as useful as it can be for me. So I'm going to want to turn the satellite imagery off so I can get a better feeling of just my outline. Maybe I want to add a few things or make any changes. So I'm going to click on the geolocation tab, and then I'm going to click on Map Aerial and click on Map Off. Now the map is turned off. Now you can see much more clearly our shade outline and our setback outline for this obstruction. If I want, I can add more obstructions to the drawing if there are more obstructions. Of course, I can add more pathways, etc. if I want to do that. Or I can go back and retroactively make changes. If I want to make this setback line bigger, I can click on the ground mount outline and say, okay, maybe I want a 400-inch setback. And now you can see this gray line has increased. I now have a 400-inch setback from the edge of that line to the start of where I want my array to begin. So now I have an area where I want my ground mount to go. I say, okay, here's my area. I'm ready to start placing some modules. So again, we're working left to right. Under version settings, it gives you a couple of questions if you want to make changes to your electrical before you jump into your mechanical layout, whether you want to change your source circuit conductor sizing, if you want to do copper or aluminum, if you want to change some system losses, your DC-AC ratio. This is stuff you can revisit as well. If you want to do the mechanical layout first and then jump back into your version setting and make any changes after you've created a layout. Clicking on the Mechanical Layout tab, we can see at the top it says Mounting System, then it says PV Module, and then it has some information about your rows and columns, your tilt angle, your column spacing, the height of the trackers, and or your fixed tilt system, and your row spacing. So the software made a guess, or it knew that we have a ground mount outline in here, so it chose ground mounted. But if you were working with a rooftop, you can see you can choose a flat roof, a carport, or ground mounted, which we're doing right now, or a sloped roof. So if you're using a sloped roof or a flat roof, please select sloped roof or flat roof. because this is a ground mount outline we created and not a roof outline, we'll be using the ground mounted option. Under manufacturer, we're going to leave it as user defined. For our rooftop designs, you will see we have many US based partners where you could choose their specific racking equipment, and you could create geometry racking layout based on exactly the way they set up their system. But for ground mounted, we're going to leave it a user defined so we can customize this a little bit further. After you have selected these options, under PV module, you're going to want to choose the module that you'd like to add into this design. So we have a large database you can choose from. After you've chosen the module you'd like to use, you can click on the Info tab. It will pull up the properties of that module for you. So if you want to see what properties we have for this module in the database, you can take a look. If the module you want to use is not in the database, please send me an email. Again, my information is listed in the description. We can add modules for you. Or if you click on the PVCAD tab, oh, it just changed views on me. So this is another view type in AutoCAD. I want to change it, so this is what you do if you ever want to change it. You can flip it from 3D modeling and then back into drafting and annotation to send it back to the default setting, which is how I like it, and then you should be back in this view. So, but it'll work fine in either view. It just is personal preference as to what type of layout you prefer in AutoCAD, and you'll see that if you're an AutoCAD user, that's something you're probably very familiar with. So moving along, after you've chosen the PV module that you want, you're going to have to make some decisions on your rows and columns. So this is the actual table now that we're setting up, the table of that you're going to have in front of you, whether it's going to be a fixed tilt or a tracker, whatever it is it's going to be. This is what you're going to use to simulate that design. So let's pretend it is 4 rows deep and it is 20 modules long. And then if I want, module frame gaps is the gap in between the modules inside of the table or individual block that we're going to array over this solar field. And then you can of course choose landscape or portrait. You're going to want to choose the tilt angle of the system. You can choose the column spacing. What is the distance from column to column? And then you can choose the row spacing of the system. After you've made those choices, you're ready to click on Make Layout. If you're doing a rooftop system, you're probably going to want to leave rows and columns as 1 by 1 because you're going to model it one individual module to the next individual module. You're not going to be using tables in the same way or trackers in a ground mounted setup, but otherwise all the rules are the same. You want to choose your tilt angle and your row spacing between the modules. And then I'm going to click Make Layout, and you're going to see it says specify layout facing azimuth relative to north 180. So 180 meaning right now if I push enter, I'm saying that yes, I want these modules to face 180 degrees, meaning straight south in this drawing. If I had a rooftop design and I wanted to be flush with the roof angle, I could click on the 2 points of the rooftop that I wanted it to follow, and it will then know the angle of that rooftop. And now you can see here is one individual fixed tilt table that I've created, and you can see it's along the angle in which I clicked. But in this example, and in most ground mount, of course you're going to want to have the modules facing directly to the south. So I'm going to click Make Layout, press enter for 180. Here's the shape of one individual table. I'm going to choose where I want that table to begin, and I'm going to click with my mouse. It will ask me Even better. Now we can see all of our tables in the design. And this is when you can begin editing your array. So you can see it avoided our obstructions, it avoided our maintenance pathway in the middle, and you can see all of the individual modules on all of the tables for this ground mount setup. Now if I want to make changes to this, I have this layout that I've created. It's quite simple. You're going to use your standard AutoCAD commands to delete and remove modules or tables by simply selecting them and pushing delete on your keyboard. You can also move modules by selecting them. Use the move command and you can move them. You can copy and paste them if you want to copy and paste. And all of this will be logged by the software, so it knows what you're doing to the modules as you're doing it to them in real time. And so you can always check in your summary tab, the very last tab, how big is this system, how many modules do I have, how many tables do I have. So I have right now, this is a 4.6 megawatt system. It's 250 panels or tables, these blocks, and then it's 17,200 individual modules. Now if I want to make a change to this, I can of course delete and move modules individually, but if I need to make a bigger change, maybe I'm changing the racking, or I'm changing the module, or I'm changing the land itself, there are a lot of things that I can do to make this easier for myself. And the biggest concept that we have that is helpful is called the versioning tool. So right now I can call this 4.6, because this is, right, is this 4.6 megawatts? Yeah, 4.6 megawatts. So I'll call this 4.6. And let's create a new version. Say, yes, I want a new version. Now maybe we found out something that because of the way the land is set up, we have to have a different row spacing or a different module. So I can come back in here and I can say, well, we're going to have a larger gap now. Change our row spacing, and maybe we even need to swap out the module too. Well, now I can swap out the module, change the row spacing, click Make Layout. Again, set my mouse where I want it to go, click on the design, click on the drawing, excuse me, and it will generate a design again around what I've laid out. So I've just made some quick changes to the row spacing, I've changed the module type, I'm on a new version, and if I click on my summary tab at the very last, I can now see the differences between these two systems. So version 1, 4.6, I can flip back over to 4.6. I can take a look at that. Here's 4.6. I can see there's 215 tables or panels, individual blocks here. And in version 2 there's 177. And again in 177, this one we increased the row spacing, but we didn't lose too much power because we're using a higher performance module. So it's a lot of things that you can play with here very quickly if you want to make changes. And again, maybe you find out, here's a point now, say maybe we found out something where I actually got a little more space. Now we have a little more space. So I'm going to do another version. We'll call it New Area. And if I go into my mechanical layout tab, maybe we have an even more powerful module now. So we're doing a third design iteration. And all this is true for rooftop as well. So everything behaves in the exact same way, rooftop, ground mount, etc. I can go Make Layout. And now I can make a layout on this slightly different area, modified area, and again compare apples to apples at our three designs. So now we have a 4.6 megawatt, a 3.8, and a 4.6. Now the 4.6 has the bigger row spacing, but we had more area that was added to our design, so we were able to quickly make a design change. So especially early on in your design process, whether it's a rooftop or a ground mount, this enables you to make sure you have the best design selected for your system. And if you can see here, it says recalculate energy. So for any one of these systems, I can click on recalculate energy and it will give me the kilowatt hours for the system over the course of the year. Let me save the drawing really quickly. And we'll go ahead and calculate the energy. Now in our software, we use System Advisory Model or we use PVWatts to come up with the calculation. So you can see here, here's your estimated energy production, almost 7 million kilowatt hours over the course of the year from this 4.6 megawatt system. Based on its location here in Oakland, California, the software does work worldwide, all over the planet. We have weather data to support these calculations. Now, as I was saying, we do have System Advisory Models, one of our performance engines. The other is PVWatts. So if you open up your Settings tab and you look under Simulation Engine, you can see which one you're using, either PVWatts or System Advisory Model, and you can switch between the two. And the reason why this is important is PVWatts is very powerful. It's a great tool, but it is not a perfect analysis. It's not the most spot-on analysis. It does not replace PVSYST by any stretch of the imagination. SAM, System Advisory Model, while it's not perfect either, it is a little more accurate in that it takes into account additional electrical calculations that PVWatts does not factor in when making a performance simulation. So preliminary, early on, it's very quick and easy to get a quick PVWatts calculation to know what you're working with, and then later on, if you want to get a SAM calculation, you can get a little more accurate after you've done the electrical wiring of the system. So you can wire your system and then you can run a SAM calculation and have a little bit more accurate example to work with. So again, back in a mechanical layout, something to keep into consideration here. At the bottom left-hand corner, you'll see it says always create a new subarray. I leave this box unchecked because I want my array to be all one subarray, meaning I'm going to be wiring it the same. I'm not going to have different inverters. I'm going to use one type of inverter for this entire array. If you're working on a residential system or a utility system where maybe one half of the array goes to one type of inverter and another half of the array goes to another type of inverter, and you have different string lengths for each section, that's when you would want to use or check this box that says always create new subarray. And then when you got to your electrical layout tab, when you're designing the electrical stringing of the system, you can clearly see which parts belong to which subarray by clicking this highlight and unhighlight button and choosing which subarray you want to work with. But in this example, I've done it all under a single subarray, one subarray, so you can see clearly how we're going to put that together. If you want to do more than one layout, so you say, okay, half of this is going to belong to a different type of inverter or stringing, there's two ways to do this. One, you could just create two ground mount outlines in the same model space. So I could cut this in two and say that there's a ground mount outline to the right and there's a ground mount outline to the left, and those are two separate areas, and then you can make a layout for each one of those and make sure you have this box checked after each time you click make layout. Or if you want, we do have the concept of an installation area. So I could use my polyline inside of this ground mount outline to draw a sub area, and then when I clicked make layout under the mechanical layout tab, it would only fill modules inside of the installation area that I drew inside of either my ground mount outline or my rooftop design. So there are two different methodologies you can use if you're doing a different electrical properties over the course of your entire system. Now that I have this laid out, so I have a design here, I like my design, it looks how I want it to look, I'm ready to move forward to the next step and start adding more electrical information for this project. So I can click on Electrical Layout, and under Electrical Layout, you'll see at the very top it says Inverters. And again, we have a large database of inverters. that you can choose from. So you can choose an inverter that you might be interested in. You can choose the specific model type that you're interested in. And then you can insert it. Click Insert. Whoops. Click Insert, and you can drop the inverter into the drawing. So I click Insert, and now I physically place this inverter into the drawing. If I click Info, just like with modules, I can pull up the electrical properties of this inverter if I want to check them. And something else, which I'm not sure if I mentioned earlier, but there is a database button here. This database button at the top of the screen, if you click on that, it'll pop open and you'll see I have inverter and PV module. So if I want to add my own module or my own inverter, I can add them to my own machine with PVCAD. So you can add them yourselves. They'll exist on your computer. If you want to add custom equipment, that is a possibility. The other option you can do is, again, shoot me an email or give me a call. Send me the spec sheet of the equipment you're interested in, and in a couple business days we'll have that information uploaded for you so you can use it in your design. There's no charge for us to do that. You help us by letting us know about new equipment that needs to be added to our database. So we have an inverter in this drawing. At the very bottom you'll see there's combiner boxes here and AC panels. I can also add combiner boxes into the drawing. So if I want to add a combiner box here, I can add a combiner box. I can also add an AC panel if I'd like to add an AC panel. So here's an AC panel. And now that I have this information in my drawing, I'm ready to begin stringing. So when you choose an inverter, under the Define String section, it's going to look at what you've created, and it'll say, here is your recommended string sizes for this inverter. Now if you want to use a different string size, you can. You just have to type it in, and you can override the string size. Are you sure you want to use a custom string size? Yes or no? I'm going to leave it at 10 because that'll nicely break up these ground mount systems for me. Now if you've done stringing on a rooftop or for a large commercial project or for a utility project, you know it can take forever, absolutely forever, and counting all the strings and getting them in place can be a nightmare. So we've tried to make that a little bit easier, especially when it comes to counting and keeping track of the number of strings you have and where they go. So if I use my string auto button here, you can see define strings. I have a string size of 10 right now. You can choose the stringing method of chain or leapfrog. Chain is one to the next, and leapfrog is obviously you're skipping and then coming back. String auto is really string by direction. So when you're using string auto, you have to keep in mind which direction you've chosen, whether that's north to south, south to north, east to west, or west to east. Now if I choose east to west, what happens is it's going to start my strings on the furthest eastmost point of my table here. It's going to go to the west, and once it gets to 10, it'll stop and start again. And so as you can see, if I choose string auto, I select these tables, press enter, it's going to do exactly that. So now I can zoom in here, I can see here's string number 1, it started here, it went to the west, got to 10, stopped, and started again, got to 10, and stopped. If there was another set of modules at the end here, if this was a table of 21 modules, then you would see that it would just leave those blank because it didn't have enough modules to complete the string set. So that is a really quick way to be able to say, hey, here's my strings, I'm ready to go. The same is true on rooftop. If you're doing a rooftop in this way, it'll work in the exact same manner. So now let me remove these strings and show you another way you can do stringing. Another option, if you want a quick and easy method and aren't particularly concerned about the string path but just want to string it so maybe you can run a more advanced electrical calculations with SAM, you can go string manual, select all the strings, press enter, and well, it shows the same path. But what happens with string manual is the software is going to choose for you how to do the stringing. And it's not always pretty. It's not always aligned like this. Sometimes it'll jump from table to table or row to row. And so it's just a way to get everything strung. It's not necessarily going to be always the route that you're going to actually use when you do the stringing. And then the last method is the most precise, and what you're probably going to use a lot of the time, especially on rooftop designs where the string path is going to snake over the roof based on obstructions or other things that may get in the way. So if I click on string manual and I type in fence for the fence command and press enter, I'm going to draw my strings. So I can choose where I want my string to start, and I can literally draw how I want them to go. And so the strings are going to follow the path that I draw. So for example, if I go straight down and then back up, it's going to follow these down and up through the modules. So it just depends on how you want your stringing to go, and it will follow this path wherever you have it. And just like before with by direction, it's going to count to 10, make a string, and then stop. Count to 10, make a string, and then stop. And if it doesn't get to 10, it'll just ignore the extras that you have highlighted. So if I press enter, you'll see it went left to right, right to left, left to right, so on and so forth for the top one, and then went up and down, up and down, up and down, up and down for the second one, because that's the path in which I drew those strings. Very simple. And you can see it's categorized these strings. And one of the nice things, if you've noticed, which is a change to our software more recently, so I had strings on here before that I deleted, and you've probably seen me using this remove string feature. And as you remove these strings and add strings, it's actually smart enough to now know, okay, you made strings before, but they're gone, so let's go back to number 1. And so the numbering system is going to be more accurate for your stringing. When you're putting together strings, you can see it's now string number 1, not string number 20, just because we happened to remove strings before. So string 1, 2, 3, 4, 5, 6, 7, so on and so forth, up to, of course, thousands of strings for a large project. So let me do a little bit more stringing here. I'm going to string auto and just select some more tables. String those really quickly. Isn't that fast? It's amazing. So now that I have some strings done, I say, okay, here are all the strings that I want. Let's remove this table just for kicks. Let's say I have all these tables strung, or I have sections of rooftop strung, and now I need to connect them. So I know that this is 6 tables is just the right amount for one inverter, and so now I'm ready to string this. So the first thing I'm going to want to do is click on source circuit conductor. At the bottom here you'll see it says draw conductors. I'm going to click on source circuit conductor. I'm going to select all the tables that I want to connect. If you select objects, it'll ignore objects that are not the strings, so you don't have to worry. Press enter, and it's going to say pick a wire alignment point. This is the point in which you want all the wires to come to before it goes to either your combiner box or your inverter. So yeah, I can connect these source circuit conductors directly to an inverter, or I can connect them to a combiner box. In this example, I'm going to connect them to a combiner box. Now if I look here, I can see combiner box 0 strings. Now when I click on this combiner box, it's going to change. 72 strings. So now it knows I have 72 strings connected to this combiner box. And you can see it's drawn all of the conductors for me. So all of my strings are connected. It's done all the wire running for me. It's actually done all the wire sizing for me as well. The same is true on a rooftop design. Now if you want to make changes to the cabling, you can. Simply select your wire and you can move them. So if you want to change how it's displayed or run in the drawing, you absolutely can do that, not a problem. And something else to keep in consideration, if you move, so if you find out, oh, my combiner box, it's actually out here. It will redraw the wire for you, but something to be cognizant of, is when you draw that rewire, you're going to want to run your bill of materials again, because it does look at actually where this wire is running in your model space when it makes your electrical calculations and when it makes your bill of materials for you. So now that I've drawn my connected my combiner box, if I want, I can connect my combiner box or boxes to an inverter. So I'm going to click on Output Circuit Conductor, then I'm going to click on my combiner box, and then I'm going to click on my inverter. And then lastly, I'm going to click on AC Circuit Conductor, I'm going to click on my inverter, and then I'm going to click on my panel. So now I have a completed system. I have, for this section of my array that I've just wired, I have my tables created with modules. They're strung properly. They've been connected from the strings to my combiner box to my inverter, all the way to the panel. We're making power. We can send it to the grid or to whatever application we need to use. So on the solar side, most of the electrical is essentially done. So now we can do some cool things. So I'm going to save this project. Project is now saved. Now that I have it saved, again, we can go back up the top here and we can start clicking on some of these buttons. So one very useful button, of course, is our single line diagram. So if I click on single line diagram, say yes, we want to create this. In the model space, it's going to place a single line based on this drawing that we just created. So here it is. So now if I zoom in on this, you can see we have 72 strings of 10 connected. Here's our inverter, here's our panel, here's our meter, here's our utility service. And the cool thing, all the wire sizing has been done before for you, and if I click on this, you'll see all these little drop-down arrows. These are changes in visibility states. So I can click on these and I can add or make changes to the design itself, depending on what I want to see in my combiner box. I'm sorry, in my single line drawing. Maybe I want an AC disconnect. Maybe I want a utility disconnect. Maybe I want to change my utility service. So I can make quick and easy changes to my single line based on what's actually at the site. I can also double click on these blocks. If I want to edit the information directly in here, I can type over it. And then I can also, if I want to add elements that our single line doesn't create for me automatically, we do have a tool palette library. And if you click on tool palettes, it's going to bring open SLD blocks, which is one of our options, which has all of the blocks that we can generate. So for example, if I need to add in a transformer, I can drag and drop in a transformer, fill out the information, click OK, and now I have a transformer block in my model space. And so in this way, if you need to add other elements into your drawing, you can copy and paste and literally draw or create a single line diagram or a 3-line diagram manually inside of the diagram, inside of the model space, by using our tool palette library and of course what it automatically creates for you. Now something neat that the software does, when you create a single line diagram or you create a bill of materials or you create an electrical summary, when you create any one of our documents, it's going to save an Excel file for you on the computer that you can reference later with all of the information about the element that you just created. So if I click on the Settings tab, you'll notice under Report Target Path, right now I have these going to my desktop, but if I wanted, I could create a folder, and then anytime I created a single line file, a bill of materials, etc., it'll create a special file in that location where all of your files will be saved. So I recommend setting that up before you start a project. I apologize I did not mention that sooner. If I go to my desktop now, I can see here is the document I just created. And in this document for the single line diagram, I can see my DC voltage drop calcs, I can see my string characteristics, I continuous, derated ampacity, inverter output, your combined output, there's an equipment schedule. It has all the calculations you might need if you're putting together a plan set, or if you just need these calculations to know more about the electrical properties of your system. Inside of this Excel sheet includes the actual calculations we used. You can see the NEC tables, how the calculations are based. This is based on North American code, but this spreadsheet is adjustable. We can make changes if needed to do this in millimeters and create an international document for you. Under Parameters tab, you'll see your information about your DC source circuit size, your DC circuit wire type, etc. You'll see its current setup, and you can override it. So for example, if I'm looking at my sheet set, I can see, okay, here's my voltage drop. Maybe I want to go back into my parameters and I want to oversize my wires. And I can go back to my sheet set and I can see how this affected my voltage drop. So I can make changes to my system based on how I want it to go. You can also save this document in a special file location. Please contact me directly for more information about how to do this, but you can actually overwrite this file. So if you want to have a very unique setup for how your calculations or other information is done, you can save it permanently into the software, so every time you create a single line diagram, it will create it in the manner in which you want it set up. As opposed to using our defaults, it'll use your defaults for the diagram. Jumping back into the drawing, so again, we've taken a look at the single line diagram, how you can put some of that information together. You can make changes really quickly. Here we've done a decent portion of our array field in literally minutes. If you get the hang of it, you can do it in an hour. Something like this could take you weeks to put together. Typically, we can do it quite quickly. Same is true on a rooftop design where your iteration may take a whole day. With some experience and having a little bit of practice, getting used to both AutoCAD and our tool set, you can do it in about an hour, a nice full rooftop design. That being said, there's a lot more we can still get from this. So the next really cool thing I want to show you is export bill of materials. If I click on export bill of materials, again, it's going to create an Excel document in the file location that we have designated. In this example, it's on my desktop. It's going to open an Excel file here, where if I pop this open, it's going to show me the number of modules I have. It's going to show me your total conductors, inverters, combiner box, AC panels, etc., your fuses, and it's going to give me a count for everything. And it's also going to show me my wire-by-wire breakdown, which is pretty nice. So I can see wire 61 goes from string 46 to combiner box number 1. It's a 10 gauge copper, and it's 3,826 inches in length. So I can see the actual length breakdown for every part and piece of the system. If you're doing racking, specifically if you're doing iron-rich rooftop racking, it will also include your mounts, length of rail, and all of the other elements for a rooftop design, but it does not include that for a ground mount setup. If I scroll to the right here, you can see we've placed areas inside of this Excel document where you could include your total material cost, installation time, labor rate, etc. So you could get a quick estimate, especially if you set up macros on your Excel, of what this system is going to cost for you to actually build. Closing that bill of materials, let's move now to an energy simulation. So I'll click on energy simulation, and again, it's going to choose whatever method I have set up in my settings tab, whether that's SAM or PV watts. And right now what's happening is it's taking all of the information about this project, and it's sending that to a server we have running where it has an instance of either SAM or PV watts. It's taking our custom weather data, combining that with the engine, and it's going to generate the calculations and send it back to us in the form of an Excel document. Inside that Excel document, it'll have all the information on a month-by-month basis and an hour-by-hour basis over the entire year. To be able to run this simulation, you do need access to the internet. For that matter, you need access to the internet to run any of our software, as you need to be able to be connected to our databases and able to use the modules and all the rest. This does take just a little bit of a minute, So while this is running, something I want to show you, if you click on your Settings tab, you'll see under here you can change from Celsius to Fahrenheit, depending on your unit, and you can also change your row spacing method, which is going to be really important depending on how you think about row spacing. Is it from north edge to north edge, meaning is it from this edge to this edge, or is it from north edge to south edge, meaning the gap in between your either modules themselves or these tables if you're doing a tracker or ground mount fixed tilt setup. So it's going to change based on which you'd like to use. And this is something that if you do change, click OK, and you're going to have to restart AutoCAD before you jump into the next part. So let's see if we're done here. I have a feeling we are. Yep. So now if I open this file, you can see here is our simulation. Subarray 1. Here are all the input parameters that we used. System losses, DC to AC ratio, capacity factor, module type, etc. Month by month information. You can see your DC output, your AC output, and then of course if you need hourly data, even more precise breakdown, here's your hour by hour, 300 every day of the year, every hour of the year. You have your AC output, DC output, cell temperature, wind speed, irradiance, etc. So you can get some really good information. If you're using PVSys, don't stop using PVSys. Again, our software is really good at doing lots of versioning really quickly. You're going to want to use this tool to find out what is the right track, how do we want to put this together, what is the best route to go, and then once you have your design finalized, using this information to input what you're going to use into PVSys if you need to make a final calculation for production. But this is going to help you get to that point so much faster. The last bit of information in here that you can grab, which is pretty cool, is if you use command PVC electrical summary. So you're going to type in the command PVC electrical summary and press enter. I got to save my drawing, so I'll save my drawing, and then I'll do it again, PVC electrical summary. It's going to create for you another document with even more electrical information. This is sort of like a hidden feature. I'll pop this open. You can see here are all your conductors, wire 1, so on and so forth, conductor size, ampacity, the length of the wire, your resistance, temperature corrected resistance, and voltage drop. So you can see the electrical characteristics of any wire run in your entire drawing if you need that very precise information as part of your design process. One more thing that's important, especially on ground mounted projects, if for example I build out a section of ground mounts here, and I'm not sure if I'm going to use them or populate them with modules right now, or maybe part of them are only partially filled with modules, I can click on this Omit Modules tool, select the ones which aren't going to have modules, press enter, and now these tables are still here in the drawing, but the modules have been removed. And so you can see these little X's, the modules have been removed. And if I need to restore those modules, click on Restore Modules, select the modules to be restored, press enter, and it will bring back those modules. So you have the option of turning modules on and off within a table if you want to turn them on and off for whatever reason. And maybe you're designing for future use and you don't have that element included. You can do that pretty quickly. Again, one of the nice things about the software is as you make changes, if you're in your paper space here, you can see revision 1, description. You can have a revision for everyone who makes a change, date, your drawn by information, have all of that populated. As you can see in my paper space here, I have project latitude, longitude, temperature information, module name, number of modules, string length, number of strings. All of that was populated automatically by the software, so I don't have to go back in and say, hey, I need to run some type of count in AutoCAD to figure out how many are there, select a layer, count them. There's no frustration on that end, and it automatically types it in for you. Also, what's kind of cool is how this is set up. So for example, if you haven't used AutoCAD before, haven't used these templates, the way it works is this is just a viewport or a window into our model space. So what I can do here, here's what we drew. So I can say, okay, this is what I want to show on this page, and you can see how this comes together for your template. So here's your first page. See, here's our single line page. So let's say, okay, where was that single line? So here it is. Okay. As far as commands that I'm using right now, I literally, you can see this light blue line around this window. That's because I double clicked in this window, so now I'm controlling what is in the window. Now I can click Z for zoom, and then you'll see the commands below: dynamic, extents, scale, window, etc. Extents is going to show you everything. Window, which is what I'm going to use right now. I can literally draw a window on what I want to be zoomed in, and it will center that on the drawing. And then when I have what I want to see in place, simply click away. Now I can move my entire object as opposed to just what's in the window. You can also add, of course, your company logo and other information in here, and very quickly you can put together a very comprehensive plan set, especially if you have a template ready to go where you can drop in the information and then be rolling, as opposed to trying to either outsource this information or just spending more time than you need to doing this type of work. So that is most of the information about PVCAD on an overall higher level. Again, when you're looking at PVCAD, the project flow, everything is going to occur on the PVCAD tab, mostly in the dialog window. The dialog window is this white box. You're going to start on project. You're going to move left to right until you get to the summary. Summary information will be all at the end, where you can compare different versions to each other. You can flip between versions in the top left here if you want to look at different iterations that you've worked on. And then if you want to, of course, save or export this information, there are a couple of different ways that you can do that. You can go and, of course, click on the A at the top right, Save As. You're going to want to save these drawings as a DWG file, DWG. If you want to export, you can do Export PDF. If you want to send PDF documents, it's going to export, for example, these pages that you created. So, for example, E.1, I go, Export, PDF, and I can create a PDF file on my desktop of this document, so I can share with colleagues or use this as part of a sales presentation, or simply if you're trying to pull a permit, this is the actual document that you'd need, that you'd go print out, whether you need to get a wet stamp or if you need to, if you can do it digitally. If you can submit digitally, depending on your jurisdiction. So again, here is the file we just created, and you can choose what elements you want to show, what you'd like to include in that drawing. On that note, this concludes the PVCAD demonstration for primarily ground mount purposes. Please follow up on our website. Inside of YouTube, you'll find more information about rooftop designs if you'd like more information on rooftop designs. As I mentioned before, if you have any questions about design in PVCAD, PVSketch, or anything relating to PV Complete, please feel free to follow up with me directly. My information is listed below in the description. Thank you so much for using PV Complete, checking out the software. We really appreciate your feedback. Any type of information you'd like to share with us, please do. I'd love to hear your thoughts and or concerns about the software. I wish all of you a great week, and I hope to talk to you all soon. Take care.